All right, gang. Circling back to the previous video, I ended strangely. I couldn't recall the command for calculating the standard error. And it turns out unless we download some packages, there's actually not a straightforward command. So what I've done is just quickly, I want to demonstrate this. Recall that the standard error in the context of a population mean t-test, what we call a one sample t-test for a population mean, is just the standard deviation divided by the square root of the sample size. So that's what I've done. I've calculated, I don't know why this is doing that, that's annoying. I've calculated the standard deviation for charge. To find the length, the number of cases, and I just called it sample, to find the number of cases, you use the length command. Again, it's not intuitively clear. It's got to be something you just got to add to your notes. If I need sample size, I use the length command. And there you can see I type sample, which is going to execute that command right there. And I get 400, which we knew. So to calculate the standard error, I would take the standard deviation, which I calculated right up here, divided by the square root of the 400. All right? Now, if you just want to make these calculations directly, you could say, well, my standard deviation is that. My length is that. So then my standard deviation is going to be 47,696.54 divided by the square root of 400. And you get the same thing. All right? So enough of that. So let's transition into steps for hypothesis testing for a population proportion. So the hypothetical example, someone's made a claim that 40% of people or what patients in this region has Blue Cross insurance. We have some reason to suspect that, and we want to test it. So we set up the null and alternative hypotheses appropriately. We set our alpha 0.05. Then we'll use technology to dive into the test statistic and p-value. So let me show you how you do that in StatCrunch. So you go to proportion stats, one sample with data. And again, if I go too fast, you have the power, unlike in a classroom, you have the power to stop me. Just hit pause and get caught up. So we want to examine insurance. Success in this case is Blue Cross, so I have to type that exactly as it's entered in my data set. And the test is for 0.4 versus not 0.4. So I can hit compute. Notice that, okay, sorry, I'm distracted. Notice the test statistic is negative 6.02, which I've noted there. And the p-value is extremely low. And what StatCrunch will do when it's extremely low, not to be confused with reporting, as we did in one of the previous videos, we can, StatCrunch uses this procedure. All right, so I just make a note of this. So my p-value is less than alpha, so I reject the null, and I'll say that our test is statistically significant. And we can conclude that the percentage of patients who uses Blue Cross is different than 40%. That's the only options I got right now. Is it 40% or is it not 40%? We reject the null, so we're left with the statement it's not equal to 40%, or it's different than 40%. To find out what it is, I use a 95% confidence interval. You can see that this interval runs from 21% to 29.5%. Both bounds are less than 40. So I conclude that the percentage of patients in this area using Blue Cross is somewhere between 21 and 29.5%, not 40% as someone has claimed. So when I write this up, I present the descriptive statistics. We have 400 patients in the study. Some of the stuff are included, so I provide the descriptive information for the categorical variable. I put these in descending order. Insurance company, I have no idea what that is. It seems, well, whatever. So there were 210 who were coded as the insurance company. That's 52.5% of the sample data. So I put these in descending order. Now, the next thing I come in, notice I have a one sample z-test. And that's indicated by the z-stat and not the t-stat that we had with the previous hypothesis test for a mean. And I just state what I'm testing, and I wanted to test the alternative hypothesis that the difference percentage is different, so different significantly from 40%. And the results reveal a statistically significant difference. This is just language you're going to want to tattoo to the brain and start implementing in your summary of the results. So the difference, probably better to be consistent. I don't think I used percentage in the previous example. So let's do it this way. So notice that my p-value, again, circling back to the previous video, if we have significance, it's either less than 0.05, less than 0.01, or less than 0.001. There's no reporting that has the p-value as StatCrunch. Displays it, and then the 95% confidence interval is reported. We also should report the standard error somewhere, and probably right here is okay, so with standard error 0.0245. Then I come in and just report the again, the descriptives, we talked about that. And I decided to put a pie chart. I think that's a nice visual on a categorical variable. And just as a review, to do a pie chart, super easy. And just copy and paste that into your document.